test that we can use to show that some series diverge. It's the nth term divergence test. So what it says here is, if the limit as n goes to infinity of the individual terms is not equal to 0, then the overall series diverges. So if the sequence of individual terms doesn't converge to 0, then we know the overall series diverges. Let's do a couple examples of using this. So show that the series, the sum from n from 1 to infinity of n over 4n plus 1, show that this diverges. How do we do that? We consider the limit as n goes to infinity of the individual terms, n over 4n plus 1, and this, by L'Hopital's rule, is going to be 1/4. So, because that is not 0, we know that this series diverges. So a necessary condition, though not sufficient, but a necessary condition for our series to converge is that the sequence of the individual terms must go to 0, must converge to 0. Another example, maybe a little bit more subtle, does the sum from n from 1 to infinity of minus 1 to the n minus 1 of times n divided by n plus 1, does this converge or does this diverge? Let's write out a couple terms here. So n is 1. This is 1 over 1 plus 2. So the first term is 1/2. When n is 2, this would be minus 1 times 2 divided by 3. Then 3/4. Then minus 4/5. And plus 5/6, and so on and so forth. And I'm writing out the sequence of the individual terms here. Really what I should be doing is let me put big plus signs here to say we're adding up all of these individually. So does this converge or does this diverge? Well, this is a little bit more subtle perhaps than the one before. Well, let's think about the limit as n goes to infinity of minus 1 to the n minus 1 times n over n plus 1. Now, in particular, let's think about the individual. So note that the terms go plus, minus, plus, minus, plus, minus. The limit as n goes to infinity of a sub n plus 1, the plus terms, they're going 1/2, 3/4, 5/6. That's basically the limit as n goes to infinity of this is going, oops, sorry, that shouldn't be not a sub n plus 1, but a sub 2n plus 1. That will take care of the 1/2, 3/4, 5/6 stuff. That's going to be the limit as n goes to infinity, n over n plus 1. That's 1. But if we look at the even index terms, those are the ones with the negative signs. That's the limit as n goes to infinity minus n over n plus 1. That's minus 1. Those don't agree. And so the sequence of terms diverges. And so overall our series diverges. So we saw two different ways in this video. We saw two different ways to apply this nth term divergence test. If the limit as n goes to infinity of a sub n is not equal to 0, then the series diverges. Well, in this case, the sequence of terms diverges, and so our series diverges. And in the other case that we did, the limit did exist, but of the individual terms, but it wasn't 0. And so this one diverges as well.